Hello, in this video tutorial I want to talk about the linear pattern in SOLIDWORKS. Using linear pattern for a part document gives you the ability to use the same feature, similar feature in an assembly environment. So for instance, in this case, I've used the linear pattern for this part, and because of that, I can benefit from another pattern in the assembly environment called, it has a weird name, but it's called pattern-driven component pattern. What it means is that, okay, you have one pattern, which in this case are these holes, in the part environment. Now, I want to use that pattern to create more instances of an assembly, a sub-assembly, or a part document inside another assembly. Now it's a bit when I put it into words, it's a bit complex, but it's probably better if I showed you. So I've used it here. I've used this feature that I just talked about, this one, and I also, in my part document, I have used another thing called L pattern or linear pattern, which is this one. Now SOLIDWORKS recognizes that pattern in the assembly environment and automatically generates these bolts and nuts for me. The benefit is, if I change the dimensions of this part, I don't need to go and change the adjust the mates or constraints of these bolts and nuts again. It's just super easy. Let me delete everything so I show you how to create this and how to benefit from it. Now, before I start, please let me tell you that this video is not about using this feature in assembly. It's actually about defining this feature, linear pattern, in a part document using Optic Reference option and equations. By using the equations and Optic Reference feature, I can easily get SOLIDWORKS to do the heavy lifting for me and make sure that these holes are always the same distance from that face. Another good benefit, another really amazing thing is, if I told SOLIDWORKS that I want the number of these holes to be 10 instead of 2, once I change the distance, change the size, sorry, to something, I'm certain that I always have the quantity that I entered here. But another thing is that I can define an offset, and the offset from these two faces is always the same thing regardless of the size of the plate itself. If I go even less than that, the quantity of the hole is the same thing, only the spacing shrinks a bit so that I get the offset that I defined inside that feature. Now let me delete everything. The problem with it is that, well, because I'm using equations, SOLIDWORKS doesn't like it when he can't find the reference for the equations, which just makes sense. So let me bring everything back to what it was normally. So I want to create a linear pattern in SOLIDWORKS. To create a linear pattern in SOLIDWORKS, please, before that, let me press F11 to make the screen a bit bigger. To create a linear pattern in SOLIDWORKS, obviously you need a feature, yeah? So in this case, it is a hole. I'm going to create another feature here, just because it's going to help me to demonstrate some of the features. It's just a simple cut extrude. Really doesn't matter the dimensions. I'm going to delete it after, but just want to use it as a tool to teach you a few more interesting tricks. Okay, So I have two features. One of them is a hole, the other one is cut extrude. I want to pattern these along these two edges. Once you want to pattern things in a part document, obviously you have many options. Like, I mean, just look at all these features, all these commands you can use under the feature tab. We're going to focus on the linear pattern. In linear pattern, you have some options as well. Out of the most easy one is using the spacing and instances. So first things first, I tell SOLIDWORKS which features I want to pattern. So I choose this one and this one, the cut extrude and the hole. The next thing, I define the direction. I say this edge, or instead of choosing an edge, I can select a face, and then SOLIDWORKS takes the normal vector of the face as the direction. Basically, you can either select a planar face, a plane, or anything linear, basically, even an axis. You can use an axis as well. It's easier to use the edge always. Once you did that, you can flip the direction using this button here. And here it's just makes sense. It's very easy. You just tell SOLIDWORKS, okay, I want the instances to be 3 and the distance between them to be this much. And there isn't more to it actually. The problem with that is that if I use that feature, once I change the size of the plate to say half of what it is now, look what happened here. So this last feature kind of was cut in half. What happened is that, okay, SOLIDWORKS says you wanted the distance between these two features to be, these two instances to be 168 millimeters, but the width of the part itself is just 200 millimeters. So that's what happens. Just makes sense. You just simply don't have enough room. If I go less, it actually throws an error and says, hey, one of these features, just I couldn't implement them into the part. Okay? So that's one problem that you face if you use the static numbers here. But what I want to use, what I really use every day at work, is this. In the linear pattern, I use the Optic Reference, because this one kind of connects this feature, the linear pattern, to the dimensions of its parent, which would be this rectangular boss extrude, this first one. And what do I mean by that? The best way probably is to just show you how it would work. So once you use the Optic Reference, there are a few inputs that you need to introduce to SOLIDWORKS. It might take longer to set it up, but it's just you set it up once correctly, and then you can use that part in assemblies everywhere you like, and you don't need to worry about this pattern feature. So Optic Reference for the what it does is basically tells SOLIDWORKS, okay, use a reference that I introduce here, which is going to be this face, and create instances of these features until you reach this reference. That's all there is to it. So, well, there are a few more options you can still define. It's like, what's the distance between those features? Okay, I know that I shouldn't go over this reference, but you still need to tell me what's the distance between each feature. So I can say 200. Okay, no worries. I can, if I say 500, look what happens. It creates it here, okay. And I say, when I go okay, it tells me, hey, this feature actually went over the reference you introduced, so I can't do it. Another good option is that, okay, not only you can define a reference, you can actually, and I'll tell you what this error message is, you can actually define an offset as well. So with offset, what happens is that SOLIDWORKS tells you, let me try something that came to my mind right now. So I was actually a bit wrong there. If you enter a value that doesn't fit into the that goes over the reference you've introduced, it just doesn't create it at all, and then tells you no copies is specified for pattern. Okay, back to the main subject. So once you introduce a reference, you get to use offset as well. So currently the offset is 0. What offset means is that, okay, create instances of this feature along this edge until you reach this reference, but create an offset from the face. Imagine the face was actually an offset. Imagine this face wasn't here. Imagine it was actually 20 millimeters just offset from where it is right now. So once you get close to 20 millimeter, never get closer to this reference than the value I enter here. So if I say 30 millimeters, it kind of says, okay, you want this feature to be, repeat this feature along this edge. You want the distance between the features to be 500. You want me not to go over this reference. That doesn't make sense. So I have to reduce the distance, say 100. This is what happens. So what SOLIDWORKS is doing here is saying, okay, 100 millimeter between each instance. I get that. You don't want me to go over this reference. I get that as well. You want to have an offset of 30 millimeters. I can make it happen. Defining all these conditions, you're going to have an instance of 4. I can change the instance. I can change the spacing between the instances. If I go over, if I go to 110, spacing, then now the instances are 3 because I've specified an offset from this face. If it created another instance with 110 millimeter distance from this one, it's going to end up somewhere here. But I have introduced something called offset 30 millimeter. So it doesn't get closer than 30 millimeter to this face. Because of that, it reduces the instances. I go back to 100. Now this face is very close to this one, but it's still more than 30 millimeter, which is the margin that I define. Now one way to play with it is using the distance. And what happens when you use the distance option or the spacing option is that regardless, SOLIDWORKS adjusts the instances, the number, the quantity, and makes sure that never gets closer to this offset to this face. But the spacing between the instances is exactly what you enter here, 100 millimeter. No matter what the instances are, it never goes above or less than what you enter here. However, you can define quantity as well. You can define the numbers instead of the spacing. You can say, okay, I want just 4 of them. And I really don't care about the spacing as long as I have 4 of these features. Just play with the spacing so you meet these requirements. One requirement would be the 30 millimeter offset. Another one would be a quantity of 4. Now, look what happened here. Once I went back to 4, this one seems closer than 30 millimeters to this edge. Well, this face is closer than 30 millimeter to this edge. Yeah, this face is closer than 30 millimeter. It's 17.5. But is this center line closer as well? No, it is 32.5. Now what happened there was that SOLIDWORKS says, okay, you defined the offset of 30 millimeter, but you didn't define a reference in the feature itself. You just told me, so I took the centroid of the feature. So as long as the centroid of the feature is less than 30 millimeters, the centroid of the feature is more than 30 millimeters away from this reference face, I think I'm meeting the requirements you defined, so here is the result. To make sure that you always say my design intent was to make sure that this face in the rectangle cut is not closer than 30 millimeter to this face. In that case, I can use this option here, selected reference. Don't use the centroid, use selected reference. Use what I tell you as the reference in the feature. So that would be this face. Now it is a bit further away. Now it makes sure that that face, that purple face in the rectangle, is exactly 30 millimeters away from this face. It also makes sure that the quantities of the instances are exactly 4, which is we entered, and then it adjusts the spacing to meet those requirements. Now if I make a measurement here, you can see that it's exactly 30 millimeter. The quantity is 4, so what it does, if I go 4,000 instead of 400, and I zoom out a bit, the same result basically. The distance from that face to this face is still 30. Where did it go? Sorry, it's playing up. The distance from between these two faces is still 30, as you can see here. And the quantity is still 4, but the spacing going to be adjusted to meet these requirements. Now, that's not all. There's more to it. Equations. We can use equations in here. So, say, you see this 30 millimeter? Where did I get it from? Well, I knew 30 millimeter is what I want because that's the distance that I defined here. I knew that, okay, this, just allow me to delete this. Yeah, so I knew that this face is 30 millimeter away from that line there. So I just simply entered 30 millimeter here and then took that as an offset. Well, what if later down the track I decided to change that 30? Say, let me go back there and shrink it a bit. Oh, I forgot to select the whole. What if I decided to make this 30 50? Yeah. Look how it behaved. So disregard the whole. Yeah. Let me just make this one 50 as well. Sorry, 60. Okay, so I changed those values, yeah, for the first instance, which was the seed, but the last instance didn't update. Like the distance from this face to this reference is still 30, yeah, but this face is 50. Well, wouldn't it be nice if this distance would have updated with this one? So so I have two features that are linked to the main feature. One would be the quantities. The other one would be the distance and offset as well. It would be nice. You can use equations for that. So instead of defining the exact value in the offset filter input, you can type in equal, which activates the equation in SolidWorks, and then just select on the feature that you want to use the as a reference. Now it kind of, because it kind of deactivated that feature for a second, so I make sure I come back here. I'm highlighted this input, and then again, come on. Yeah, all right. So that feature is selected now, but deselected that one. Okay. Anyway, so you play with these selections here, but at the end of the day, all you want is to get SolidWorks to show you that reference offset, that reference dimension. So you type in equation here, and then you select that dimension from the sketch. As simple as that. If you know the name of it, so in this case it's D1 at a sketch 4, you could have just simply typed it in. You didn't need to highlight all these features. You simply could type in equal sign, double quote, and then D1 at a sketch 4, and it would work the same. So what happens now is this offset is always the same value as that. It's now 50, as you can see. It's the same value as this dimension. So if I go 30 here, it moves it a bit further to the right to meet that requirement. So these are the way you set things up. Obviously, I don't need that rectangular feature, so I just delete it. What happens is that because there is an equation pointing to it, now you have to go to the equation manager, manage equations, and delete that one as well. All right, so let me set it up correctly for the last time. This one was 40, I believe. This one is 40 as well. And the size is correct, so I just simply I press F11 to make the screen a bit bigger for you guys, and then go to the linear pattern. In the linear pattern, I have to choose the feature that I want to pattern, the directions, which would be this edge, make sure it points to the right way, and then up to reference, defining the reference, defining the offset, and defining the reference in the feature itself. In this case, it is the center line, and the quantities that I want, just 2. Doing the same thing for the other direction, I'm gonna use this edge as the direction. I'm gonna use the same options here, use the same option, which is the up to reference. Out of the box, it chose the spacing as the defining input for the feature. The spacing is 10 millimeter, so it created enough of these holes until it reached the surface. The offset is set to 0, so the moment the center line of the hole of the last instance reached this surface, reached this reference, it stopped the pattern feature. I'm going to adjust it to 2 and define a offset of an offset of 40 millimeter, as much as this one is. So now if I choose this checkbox, look what happens. It doesn't generate this one as well. So this checkbox, if you wanted to pattern the seed, which was the initial feature, if you want to pattern that one along the second direction, you can use this option. Now I just keep it as unchecked because I want it to generate 4 holes for me. And that's there is to it. I just press Ctrl S. Let me rename it to pattern. Let's leave it as pattern 4. When I go back to the assembly, it will throw some errors at me because I deleted the initial pattern. As you can see, you can't find the reference for this mate, so I just select it here, and now everything seems okay. Control Q, everything okay. 330, I want to shrink it to a bit less than that. This derived pattern needs to be updated to, and I have to select the right pattern. Done. That's all there is to it now. I don't need to worry about the whole pattern in this file anymore. Later, if someone else wanted to use it, all they have to do is to come here, change the size to what they want, and everything seems to be working just fine. I just have to make this hole a bit further down away from that edge to give some distance for welding. There's all there is to it. So that was it for this video tutorial. I hope you liked it. If you did, please press the like button, and if you have any questions, ask it in the comment section below. I will answer to it. Thank you so much for your time today.